Okay. So systems of equations. All right. And the systems of equations just means we're now going to be able to use two variables. All right. So with that being said, number one, who's got the first equation? Come on, come on, come on. There are 77 quarters and dimes. What's the first equation? It's gonna be a long 30 questions. Go. That was really hard. Q plus D equals 77. That was really hard. Quarters and dimes together combined to make 77 coins. All right, now the next one could be challenging if you don't know what the value of a quarter is. And believe it or not, I had high school kids didn't know what a quarter was. All right, because we don't use currency anymore. All right, everything is done with a credit card. So people don't know values. All right, so a quarter is worth what? So what would be the second equation? No, no, no. Quarter is not 25. 0.25. So it would be 0.25 Q plus the value of a dime. 0.1 or 0.10. Doesn't matter.
No.
Now, how much money is the value of the coins worth? $12.50. All right, notice now, please, that this is talking about how many coins. This is talking about the value of the coins. All right, the quantity and the value. All right, don't mix those things up. All right, anybody have any questions with that so far? Right now, it's just a system of equations. All right, so now we're back to what we did before the holiday. All right. So if I want to do this without decimals, all right, I can multiply this by 100 or just move the decimal over 2 places. And that would eliminate all the decimals. So let's write 25Q plus 10D equals 1250. And then I have Q plus D equals 77. All right, so now we have this system of equations. All right, I need to figure out how many quarters there are. All right, so now you're going to be smart. I'm trying to figure out how many quarters. So what letter do I need to eliminate? D. I'm trying to eliminate D because I'm trying to solve for quarters. All right. So what number, if I'm trying to eliminate D, needs to be at this highlighted spot right there? What is that? What is it? -10. Now, Luca, that was great. Why does it have to be -10? So it cancels out the +10. Some of you don't know this yet. I don't understand it. You want the variable to cancel out. So one has to be positive and one has to be negative. So, Luca, what do I have to do to this entire equation? Multiply it by -10. So everybody's going to multiply that by -10. Now, when you don't know something, now you speak up and you say, man, I have no idea why I'm multiplying by -10. Can anybody say that? You're canceling out the D.
Oh, yeah, I meant that, but like,
That's why you're doing that, because -10 and +10 cancel out. All right, that's why. The only way to cancel out a D is if one is positive, one is negative, and they're the same number. All right, anybody have any doubts about that? So now when I multiply by -10, that gives me -10Q minus 10D equals -770. Now, when I combine these two equations right here, what happens to 10D and negative 10D? They cancel out. So what am I left with? 15Q equals 480. So how many quarters were there? How many? You have a calculator. 32 quarters. All right. You have 32 quarters in your collection. Now, if I wanted to, could I say how many dimes did you have? Yeah. You would just plug 32 into this equation, and that would tell you the number of dimes. Do I care how many dimes there are? No, because it just says quarters. All right. It just says quarters. All right. So again, setting it up is the hard part. Solving it should be a little bit easier. All right, does anybody have any questions with that solving part? Misha, you have any questions? Perfect. All right, here we go. Number 2. All right. The sum of two numbers is 32. The sum of two numbers is 32. Somebody write an equation for me. Yeah, but let's do it alphabetically. X plus Y equals 32. Okay. Now, the next statement. One number. Does it matter if you choose X or Y? It makes no difference. It makes no difference. So what letter do we want to use?
Y.
Y is, now in math, is equals. Now, how do I write 4 more than the other? X plus 4. Now, again, I'm really trying to get some of you to put the jokes aside and concentrate and try. All right. You're not getting any better if you're just sitting there clowning around. All right. We have one more test. That's it to get your grade up. And the last test is on word problems. All right. Should be pretty easy if you know how to solve. All right. If you did good on the last test, this should be easy. All right. But if you don't try translating from a sentence to an equation, it's not going to be easy on Friday. You got to try. All right. Does anybody have any doubts about that right there? All right. Now, how do I solve this? We could move the X over, or I could just call this a what type of a problem? Substitution. Why is it a substitution? Because we have what Y is. What does Y equal? So that means wherever I see a Y, I can put what? So here we go. Wherever I see a Y, Misha, I can put what? X plus 4. So here is my Y value. What does that become? So now I have X plus what? You can put parentheses, what? X plus 4 equals 32. The highlighted Y became X plus 4. Now, really, was there any need for those parentheses? No, because I'm not multiplying by anything. All right, anybody have any questions? So now if I solve that real quick. Good. 2x plus 4 equals 32. Now what? 2x equals 28. So x is 14. X is 14. So if x is 14, you should be able to plug it in. Y must have been 18. All right. I just don't think that's that hard. All right. Anybody have any questions before we move on? All right, let's try. I think we're out. Just run up there and get some more for me. I appreciate it. Sorry about that. Thank you. Hurry, hurry, hurry. Okay, let's read number 3. The length of the rectangle is 3 less than twice the width. The perimeter is 54. So who remembers what the formula for perimeter of a rectangle is? Add up all the sides, but there's a better, what is it? Tell me. Yes, the perimeter of a rectangle is 2L plus 2W. You have to know that. Now, what did they say the perimeter was? 54. So I can just put 2L plus 2W equals 54. Anybody have a problem with that? Now, does anybody notice something here about the 2, 2, and the 54? We can make it easier. What can we do with all those numbers? Divide by 2. Right? So that means that the length plus the width had to equal what? 27. Wow, look at that mental math. Length plus width equals 27. Does anybody have a problem with that? Go. What's 54 divided by 2? Guess what? Now, again, just to make sure, for those of you guys, listen, Molly, the one thing I like about you is just going to ask. That's what I wish everybody would do. Just ask if you don't see something. Sitting there, not knowing, by the time I get to number 30, if you're not asking me about number 3, it's going to be frustrating. All right, as we go down the page, you should be getting better. Now, if you don't know that, divide by 2, divide by 2, divide by 2. Nobody cares what you know and don't know. Speak up if you don't see it. Tell me, Jolie. Because I'm just observe that 2, 2, and 54. If I want to make the problem easier, I can divide by 2. If you don't do that, is it going to affect the problem? Nope, just makes the problem easier. Okay, whenever you can divide by the same number, you should do that. Okay, so now I have this. The length is 3 less than twice the width. That's why at the beginning of the year, we worked on these for a week. You're supposed to be able to make that translation now. Come on, no daydreaming. What is it? 3W. Say, write the whole thing for me. Length is what letter? No, length is what letter? L. L. What does is mean? Equals. How do I write 3 less than the width? 3 less than twice the width. Yes, thank you. That's what I need from everybody. The length is 2W minus 3. The length is 2W minus 3. We did that for a good week. All right, because the translations are important. Now, everyone should be able to say, okay, I see that. What does L equal? So that means wherever I see a what? L, I can put what? See this L right here. What does that become? 2W minus 3. So now I just say 2W minus 3 plus W equals 27. Misha Martin, how is that? You sure? All right, now from there, we're just solving. Now look, some of you guys are getting smarter, so look up on the board. Here's what I'm expecting from everybody. What's 2W plus W? So everybody put 3W. Don't put minus 3 anymore, because what are you doing to the minus 3? You're adding 3 to the other side. 3W equals 30. Now, eventually, you'll just be able to say 3W equals 30 and W equals what? This is one-step equation, actually. Everybody should be able to do that. All right. So now we know the width is how much? 10. Now, all right, if the width is 10, it says find the dimensions. That means you have to tell me what the length equals. Length equals 17. Now, what I want everybody to do is practice putting the units. 10 units by 17 units. That's what we're looking at. I don't think that's that hard. What? I don't know what you mean. Why didn't I multiply those by 2?
No, because it's 2L plus 2W. You divide this one by 2. Would you multiply the length and width?
No,
Why not?
because the length and width have to add up to 27, right?
Okay. So it doesn't matter, like if you do multiply them by 2, it's still the correct answer?
Here's what you're asking me. Listen, you always ask me good questions. I'm gonna try to show you something. Look on the board. 4 plus 6 equals 10, right? If I divide by 2, it's still a true statement. You understand what I'm trying to tell you, right? Just because 2L plus 2W equals 54 is exactly the same. It doesn't look the same, but it's exactly the same. L plus W is 27. I'm not asking you for 2L or for 2W. I'm asking for L and W, right? You're having trouble plugging 10 in for W. What's 2 times 10? Minus 3. You with me? You're substituting in. All right. Anybody have any issues with that? Anybody? All right. Flip the page. Let's go. Number 4. The sum of two numbers is 66. The smaller number is subtracted from 2/3 the larger. Oh, all of this sounds confusing, but guess what? It's not. It's not. It's not confusing at all. All right. So here we go. The sum of two numbers is 66. So how do I write that? I just like to stay with old-fashioned x plus y equals 66. Now, I think it's important for you to identify which one do you want to be smaller and which one do you want to be larger. Does it really matter? No. So off to the side, I'm going to put x is equal to the smaller and y is equal to the what? Larger. That's just for my own notes because I'm going to make some, when we read the second sentence, I'm going to have to know the difference between the smaller and the larger. If the smaller number is subtracted from 2/3 the larger, someone tell me what that means. Somebody tell me, Misha. So is it x minus or minus x? Shh, I want her to do it. X minus? Nope. The smaller number is subtracted from what? You see what I'm saying, right? So now, again, I know that's hard. You don't have to raise your hand. You don't have to tell me anything. I know that's hard. If I say 5 is subtracted from 10, what's the answer? 5. Because you're doing in your head 10 minus 5. Does everybody understand what I'm trying to tell them? If you don't, if you just read it literally, you're going to make a mistake every time. You can't read it literally. All right. The smaller number is being subtracted from something else. So everybody should start out by writing minus x. That's what everybody should be doing. Writing minus x. You're subtracting x from something. Misha, what am I subtracting it from? What's the larger one? So 2/3 y. That's exactly correct. Everybody should be able to do that. The result, what does that mean? Equals, or the answer. Okay. Now it's saying a little bit harder. The result is 1/3 the positive difference of the original numbers. Now they're trying to throw you off there. The only way I'm going to get a positive difference, do I do x minus y or do I do y minus x? Because if I do x minus y, it's going to be what? It's going to be negative. Does that make sense? I want the positive difference. So the positive difference would be what? Y minus x. Now, what do I have to do with y minus x? Multiply by 1/3. All right, I have to put parentheses around it and multiply by 1/3. And again, I'm trying to tell you that is kind of difficult. All right, that's kind of difficult unless you break it down, unless you try it on your own. What?
Why would we put the 1/3 in parentheses around the 2/3 y minus x?
Because that's not what it says. Right? The result is, come on now. I'm trying to show you something. The result is, that's where the equals.
Oh, got it.
Then after that is the 1/3. 1/3 of what? 1/3 of y minus x. What, Misha? Good.
Where did the 66 go?
The 66 is from this right here. Good question. The 66 is from the first sentence. This right here is this.
Oh, so that's like a whole different thing.
That's a whole different thing.
Oh, I would-
Boom, we're on something else. Right? The second sentence is your second equation. There's always going to be two sentences. Anybody have any questions with that? Do I like fractions? Well, they don't bother me, but most kids have trouble with them. So we're going to get rid of the fractions. Now I'm going to show you how to get rid of fractions. Now it's not easy. So I want everybody to look up on the board. All right, I don't like fractions. So I'm going to take and I'm going to multiply everything through by what? 3. Thank you for whoever said that. Why am I multiplying by 3? Because the denominator of both fractions is a what? Is a 3. And so if I multiply by 3 and divide by 3, what are they going to do to each other? They cancel out. So now I want everybody put the bracket around, and then I want to put a 3 out in front. Now here's where the biggest mistake comes in. If I multiply off to the side here, I want everybody to understand me. Off to the side, if I said 5 minus 1 equals 2 times 2, is that a true statement?
Yes.
Right, that's a true statement. Right now, please, I'm trying to explain to you, when you forget something, you can make yourself little problems and you can solve it. So I'm going to multiply this by, let's say, 3. Now, if I multiply the left side by 3, do I multiply the 5 and the 3 and the 1 and the 3, or just one or the other? All of it. So that's the same as 15 minus 3. Does everybody agree with that? Now I'm going to multiply the right side. Do I multiply both 2's by 3 or one 2 by 3? So if I multiply both of them, I'm going to get 6 times 6. Is 15 minus 3 the same as 6 times 6? No. Nope, it's not. So now do I multiply one or both? Let's try one. 6 times 2. Is that true?
Yes.
Now you understand you're multiplying one of them, not what? What is the difference? One is subtraction and the other is, do you distribute through multiplication? No. Do you distribute through subtraction? Yes. Do you distribute through multiplication? No, you don't. So now if you paid attention, you learned something important. All right, if you're daydreaming, you missed something really important, actually. Stop daydreaming. All right. So now when I go to my problem and I multiply everything through by 3, you're going to understand and you're not going to ask me a question. So when I multiply the left side by 3, I get what? 2y minus 3x. Come on now, everybody take a look at multiplying the left side by 3. Did I multiply by the left side by 3 properly? Equals. What does it equal? Y minus x. Thank you for listening. I had a choice. I could either multiply the 1/3 by 3, or I could have multiplied the y minus x by 3. So what did I choose? The 1/3, because it did what? Canceled out. Now I have no more fractions. Is everybody with me on that?
If you, when you're reducing the second half of the problem, does it matter which one you
It doesn't matter. You're going to get the same answer. All right, so now I want everybody to look at this. This right here can be cleaned up. Right? Does everybody agree with that? There's a bunch of X's and Y's, put them together. So if I move the Y over, what does that become? Come on now. 1y. Why does it become 1y? Because I'm subtracting it. So that gives me y equals. Now what would y equal? Y would equal what? Come on now. 2x. Why is it 2x? Because I'm adding 3x to both sides. So be happy with that. So what does y equal? Y equals 2x. Y equals 2x. That means wherever I see a y, I can put in what? Right, Misha? Wherever I see a y, I can put 2x. X plus 2x equals 66. 3x equals 66, so x is equal to 22. So that means y is equal to, notice I'm drawing arrows for you, 44. All right, that was kind of hard. All right, that was kind of hard, actually. All right, so put a star by that one and tell yourself to review that. All right, here we go. Number 5. Okay, so we're talking about fractions, correct? Now, some of my kids forget. The top of the fraction is called the numerator. The bottom of the fraction is called the, so let's practice, n over d. That's what they're referring to. They're referring to this fraction right here. If 1 is subtracted from the numerator, what is the numerator going to become? You're amazing. N minus 1. That's what happens when you sit up and pay attention the whole time. Do I change the denominator? No. The resulting fraction is what? 1/3. Nice. That wasn't hard. Now, the next one. If what? 2 is subtracted from the denominator. So how do I write that new fraction? N over d minus 2 equals 1/2. There you have it. What?
why is n not n minus 1 in the second problem?
Because they're referring to the original fraction. Right? This is what I would try to tell you. This is the original fraction right there. All right. So if I subtract 1 from the numerator, it's going to be 1/3. If I subtract 2 from the denominator, it's going to be 1/2. That's what that means. What?
So the first one's equation will just.
That's exactly correct. Exactly. Come on, Molly. What? You sure? Okay, now we have a proportion. What do we do generally with proportions? Say it again. Cross multiply. That's what we do. We cross multiply. So I'm going to do this first because that's just going to give me a what? D. So I'm going to write D equals 3 parentheses n minus 1. Everybody okay with that?
Yeah.
So I'm just going to carry that a little bit further. D is equal to what? 3n minus 3. Cross multiply on the second equation. 2n equals d minus 2. Now, does everybody agree I can just move that 2 over, right? Do I have to? No, I don't have to, but I'm looking at it and saying, well, that just means the d equals 2n plus 2. Does everybody agree with me on this? Come on now. Jackson, you agree? You're not just writing down my work, are you? Now, again, somebody was doing a good job. This is number 1, and this is number what? 2. Now I have d equals 3n minus 3 and d equals 2n plus 2. So what's true? What can I do? Come on now. D equals what? So wherever I see a D, I can put what? 2n plus 2, right? So these two things, let me say this again. These two equations are equal to, D is equal to 2n plus 2 and 3n minus 3. So what's true about those two things? They are equal. So you would say 2n plus 2 equals 3n minus 3. All right. Now I kind of fumbled through that a little bit. Does anybody not understand what I just said? What?
So, I am confused.
I know that. That's why you're asking me a question.
For the 2n plus 2 like d equals 1 2. I don't simply got that.
You don't understand how I got what?
D equals 2n plus 2.
Do you not see I just added 2 to both sides here?
But why did you add 2?
Because up here I had D equals. So I just said, well, it'd be nice if I had D equals, and then I just set them equal to each other. You don't have to do it that way. You can just come down here and replace D with 3n minus 3 if you want.
Now I'm even more lost.
Well, you're in a algebra class, so we can start there. You found yet?
So I don't understand how you got that.
I don't, to me, I don't, look, I just have this equation right here. 2n equals D minus 2. I just added 2 to both sides.
Couldn't you just like move the d over and move the 2 out?
The D would become negative then. D is good because it's positive. I don't want to move D because it would become negative. I want to get rid of the minus 2. Completely not necessary, but since this up here, we just had this equation, D equals 3n minus 3, I could have said, wow, if I let D solve this for D, I set them equal to each other. And then I go from there. All right. So what's the numerator end up being?
5.
5 is what I got. Is everybody good? All right, so the numerator equals 5. Now, if the numerator equals 5, what's the denominator? 12. Thank you. Wow. Paying attention, concentrating the whole time makes a big difference. And when you don't know something like Evan, even if I'm a little cranky, he still's going to ask me a question. All right. I don't care. All right. Be brave. D equals what again? 12. Some of you are having trouble with 5 times 2 plus 2 or 5 times 3 minus 3. Right? Anybody have any questions with it being 12? Evan. So what is the original fraction? 5 over 12. Now let's show you how great you are. The original fraction is 5 over 12. If I subtract 1 from the numerator, what does the numerator become? 4. And what does 4/12 reduce to? 1/3. If I subtract 2 from the denominator, what does the denominator become? 10. What's 5/10? There you have it. So you know you're right. All right, you know you're right. Anybody? Anybody? That's not bad. All right. Now, again, believe it or not, out of everything I teach you, this is by far the most important thing. Being able to reason. That's what your objective is. Think things through. All right. That's why I fuss at Jackson sometimes, because he's just writing down my answers. I don't want him writing down my answers. You writing down my answers is not making you smarter. All right. You got to do it yourself. All right. Now, your job tonight, try number 6. Because number 6 is just like, oh, I didn't say we're going anywhere. What time's the bell ring? All right. So everybody try 6. Hold up. And 7. And 8. 6, 7, and 8. That's your job tonight. 6, 7, and 8.
Bro, who didn't even know the answers in the past?